In the first half of the 20th century, power steering was not an option. Prototypes were too expensive for production. But during World War II, the British and American military began to use it in heavy vehicles such as armoured cars. Then in the 1950s, manufacturers began fitting it to passenger vehicles. These hydraulic steering pumps are the steering muscle in muscle cars, providing power assistance to give the driver more control and an easier ride. Using computer software, the pump is first designed to fit a specific class of vehicle. Next, a plastic model is printed, made using a 3D printer. Here's a time-lapse video of that process. The plastic model is then removed and sent along with the computer design to a casting facility, which produces the parts for the aluminium pump housing. Back at the factory, 12 of the castings are mounted in a machine with computer-controlled tooling. Once activated, the system moves the rack of castings into position. Then each face of the castings is machined by the tools. Bearing holes are bored into the center of each, and threaded holes are drilled for bolts. It's precision work. However, it's still double-checked by a device known as a coordinate measuring machine. The pump housing is clamped in the machine. Then a ruby-tip probe scans the dimensions. The machine analyzes the information, verifying that every part of the housing meets the precise specifications. With that confirmation, the part is removed. And here's the pump housing in the various stages of production. Elsewhere in the factory, a solid piece of aluminium is being machined into a fitting for the pump's pressure bore. It cuts the circumference and carves out the complex geometry in the center for controlling the flow of power steering fluid. Another tool then carves a thread to screw the fitting into the pressure bore, after which a fluid bypass hole is drilled. Blue anodized coating will protect it from corrosion. Next, the pump housing is locked in a honing machine. The machine floods the pressure relief bore with lubricant as a stone hones the inner diameter to a precise tolerance. The pump housing is then moved to a press, where a bearing and shaft are inserted in the center bore. A tool is then placed over the bearing and shaft to correctly align them as they're pressed into the bore. Once the bearing has been firmly embedded, the tool is removed, and a snap ring is inserted in a groove to hold the bearing and shaft in position. The power steering pump is then turned over, and O-rings are installed to seal the pressure section. Next, the cam ring and the rotor are installed with vanes. As the rotor spins, the vanes will move in and out, collecting hydraulic fluid and pressurizing it to take the load off the steering wheel. Once complete, this critical subassembly is installed in the pump housing and is then locked into place in the four corners. The power steering pump is turned over, and the end of the pressure bore is sealed with an aluminium plug and copper washer. Next, the pressure relief valve is inserted in the open part of the pressure bore. This is held in place with the special flow fitting we saw being machined earlier. And that is tightened to the correct torque. Installed next is the intake port for the hydraulic fluid. Screwing this in place means the power steering pump now has all its working parts. Here's a look at the transformation with this display model, allowing us to see inside. The power steering pump is now tested at this station, where it's run as if it were in a racing car. A computer measures its performance and will confirm if it meets all the technical requirements. The Our steering pump is now ready for the twists and turns of professional racing. Or maybe getting into that last tight spot in the car park.